Hi, I'm Philip, and in this video I will look at the accuracy of the MetroY Form 3. I do this by 3D scanning a calibrated micrometer. You may already know the approach since this is part of a series. I've already tested with the Revopoint MetroY Pro, with the Creality Sermoon S1 and the Einstar Rockit, and there will other scanners be added to this test in the future. If you already know the process, or just want to see the results, you may skip to the point where I edited in the timeline. So now let's look at the scan process. I placed the micrometer on the turntable of the MetroY Form 3, and the specialty with the MetroY Form 3 is that the turntable itself provides the tracking. So in the turntable there are like optical encoders, and these are used to position the single scans it does while rotating the turntable. So it doesn't use any markers or features of the part you're scanning. I placed the micrometer at this awkward position near the edge of the turntable, so the anvil and spindle, so this and this part, are centered in the middle of the turntable as much as possible, since I want to keep them in focus of the scanner most of the time. I checked that the turntable had a stable position on the turntable. The micrometer had a stable position on the turntable, and that it didn't wobble while rotating, since this would have thrown off the results. Now, let's look at the micrometer a bit more. The micrometer itself is set to 125.00 millimeters plus minus 0.01 millimeters. So this is the calibration of the micrometer with like a calibration stick it comes with. I had to add scan spray to the anvil and spindle since they are regularly polished to a mirror finish. For this I used a thin coat of SR Blue. This has a thickness of roughly 8 to 15 micrometer as to the manufacturer specs. So I subtracted 2 times 8 micrometers from the 125 millimeters to come out to 124.984 millimeters as our nominal. Now to scan settings with the MetroY Form 3, I used a high resolution scan. So I used a smoothing value of 20 with it, and 1 rotation of the turntable with 8 scans per rotation. And I used the meshing setting high detail for post-processing, and I did 6 repetitions of the scan. Now let's look at the scan results. Here you can see the bare point cloud of multiple scans within the scanner itself. So with the MetroY Form 3, you have like the web interface of the scanner in your local network. And here you have the mesh scans now opened in quick surface. And as you can see, we have these like bulbous ballooning protrusions of the scans. This is due to the fact that the MetroY Form 3 always performs hole filling. And with these open scans of not complete parts, you get like this, these protrusions. Currently, there is sadly no option to disable this, but keep in mind you can merge multiple scans or align and merge multiple scans together to get a closed model, and then you don't have this problem with hole filling. Now to the measurement process. How do I get my readings? I import the STL files and the scan file into Quick Surface. Then I extract a plane on the anvil, in the face of the anvil, by using the automatic selection of Quick Surface. So it basically selects all the points that are in a plane, and then it creates a plane, a space feature, and then I create the second plane on the anvil, constrained to be parallel to the first plane. And now then I can measure the distance between the 2 planes, or between the edge point of the 2 planes, since they are in the same orientation and size. Now let's look at the stated accuracy of the MetroY Form 3 as to the manufacturer specs. So you can see resolution and set accuracy. I used a distance between the scanner and the micrometer center of roughly 30 centimeters. So we are somewhere between the values of like 37 and 65 microns and 35 and 150 microns. So I would say taking the setting somewhere a bit below 100 microns should be our goal. So the nominal value we want to reach is 124.984 millimeters plus minus 0.01 millimeter. So this is the micrometer in real life. With the MetroY 3, we have a mean reading of 124.889 millimeters and a delta mean of minus 0.10 millimeters. So it's roughly at the stated accuracy spec. Comparing this result of the MetroY 3 to other scanners outside of the laser scanners, in orange we have the readings of the MetroY 3, and in this pink we have the auto turntable mode of the MetroY Pro. So this is like the closest comparison of scan process I currently have. And in blue we have the target or the nominal. Let's look at the delta mean. That's, I guess, the most interesting part. With the MetroY 3 we are at minus 0.10 millimeters, and with the MetroY Pro we are at minus 0.06 millimeters. So the MetroY Pro is more accurate. One of the reasons could be that the MetroY 3 has a type of foam board calibration plates, so they aren't from glass or other like low yielding material. It's basically foam with a hard foam, some sort of plastic covered hard foam, whereas with the MetroY Pro we have glass plates, or I guess maybe some quartz glass plates. I'm not completely sure about the actual material.